potential. Consider a half cell. Initially, both electrodes and electrolyte are in neutral state. Under certain applied condition, the electrodes start dissolving. The concentration of M plus N increases, thus making the electrolyte positive and leaving back the electrons on electrode and thus making it negative. Thus, this charge separation between electrolyte and electrode includes a reverse potential which does not favor further dissolution of electrode in the electrolyte. Combining these two factors, further dissolution of electrode in electrolyte stops and an equilibrium condition is achieved, and the potential difference between electrode and electrolyte at this state is called electrode potential. Standard electrode potential. Whenever a solid species is considered, its concentration term will always be unity. Therefore, we can see that the concentration of M plus N is only responsible in determining the electrode potential. Thus, if concentration of M plus N is equals to 1, the electrode potential under this standard condition is known as standard electrode potential. It is always denoted by E naught. Cell potential. The potential difference between the two electrodes of a galvanic cell is called the cell potential and is measured in volts. The cell potential is the difference between the electrode reduction potential of cathode and anode. E naught cell is given by E of cathode minus E of anode, where E naught cell is known as where E naught is cell potential, ERP of cathode is reduction potential of cathode, and ERP of anode is reduction potential of anode. Cell notation. Cell notation and cell potential. Anode is written on the left side and cathode is written on the right side. Phase boundaries are indicated by vertical bar or slash. Concentration of the electrolyte in the anode and cathode must be written in parentheses. In case of gas, the partial pressure is to be mentioned in atm. A comma is used to separate two chemical species present in the same solution. A double vertical line denotes that a salt bridge is present. EMF of the cell is written on the extreme right of the representation. Note that salt bridge is not indicated, which implies that the electrolyte is common to both anode and cathode compartment.